Hello, everybody. Welcome to Olga Channel once again. Today is Independence Day. I want to wish everybody happy independence. And don't forget to pray for Ghana because if Ghana goes well, your life will be better. If Ghana doesn't go well, then you know what will happen. All right, so today I just want to solve some questions with us. Basically on probability. Yes, just some questions that I think it will be helpful because they weren't easy solving, but then by God's grace, I was able to come out with solution. So I think it's recommended or commendable to share with you guys. All right. So I'll share my screen. I'll dive right into business. Uh, uh, uh. All right, guys. All right, everybody. So, what is the question? Show yourself. All right. So, I want us to solve some question. Obviously, under quantitative methods. All right. So, without wasting much time, let's see some of the questions and how we'll go by it. So, some of them you have shortcuts way of using the calculator to solve for them. But then I don't know how to get the manual calculator um com- on the screen or on the web, like you get it. So I'll try as much as possible to do one of the workings so that we'll know whether the answer is correct or not, because I'll be doing it with my calculator. You get it. So the first question that I want us to look at is this question. It says, Hisense Ghana produces and sells HD TVs. The HD TVs are inspected at the end of the production process at a quality control station. Out of every batch of HD TVs, 4 are randomly selected and tested for defects. Given that 20% of all batches are defective, what is the probability that each batch of HD TVs will contain only 2 defective HD TVs? So this is the question. So before you even start diving and solving, you have to ask yourself, what type of probability is this? Because each type of probability has its own method or way of solving them. So if you are not, how should I put this? If you don't identify the type of probability you are dealing with, then you'll not be able to know what type of solution to assign to that. You get it? So with this question, when we realized that I said out of every batch of 8 DTVs, 4 are randomly selected and then tested. So we realized that this is talking about binomial distribution. Even when we look at the second sentence, it says, given that 20% of all batches are defective. So it's like he has given you um, an aspect of the probability. So we know that if 20% are defective, then it means that 80% will be what? How should I put it? Will be non-defective. So binomial distribution is like two ways. So if it's not this, it's that. If it's not this, it's that. So realize that this is a binomial distribution. All right. So we use the binomial way of solving probabilities. So first, let's see what the question is asking now. The question says, what is the probability that each batch of ADTVs will contain only 2 defectives? The reason why I'm saying you read the question first is sometimes in the question they'll give you, let's say, if the question has said, find the probability that each batch of ADTVs will contain only 2 non-defective HDTVs. So with this one, you see the question gave you 20% of what defective, and the question is asking you to find for non-defective. So the probabilities will be what? Different. So you have to first know the question, what the question is asking you to what to do, and then the preambles. All right. So we know that with the binomial distribution, the basic formula is, so let me write it here. So in a binomial distribution, the formula is n factorial let me write this. I think that would be better. So formula is n factorial divided by x factorial into brackets n minus x all brackets close factorial times p raised to the power x times q raised to the power n minus x. So in a binomial distribution, this is the formula we use. So after getting the formula down, you have to know what the various variables would represent, right? So the n here represents the sample size, right? The sample size. And then the x here represents like what the question is asking you to look for. What the question is asking you to look for. Then the p here represents the probability that relates to the x, the probability that relates to the x. And then the q here represents the probability that relates towards the other side of the x. So in our question, realize that the question says, let's go back to the question. So here, the question says that Hisense produces and sells HDTVs. The HDTVs are inspected at the end of the production process at a quality control station. Out of every batch of HDTVs, 4 are randomly selected and tested for defects. So this is telling us that 4 here becomes our sample size. 4 here becomes our sample size because for every batch, we pick out only for investigation. So 4 here becomes the n in the formula. So here our n is equal to 4. Then we are looking for x. Let's go on to the question. So given that 20% of all batches are defective, what is the probability that each batch of ADTVs will contain only 2 defective? So the question is asking you to find for what only 2 defective. So this 2 becomes Rx. So Rx here is equal to 2. Then when we come back to the question, it says, given that 20% of all batches are what? Defective. And then I said that the P is what the probability that relates to the X. So the X was what? To find 2 defective. That means you're looking for probability that there will be a defective. And in the question, it said the probability that there will be a defective in the batches is 20%. So here our P will be what? 20%, which is the same as 0.2. So here our P is equal to 0.2. Then if our P is 0.2, then our Q will be what? 1 minus 0.2, because we said probabilities sum up to what? To 1. So if we know that 20% is defective, then we have to know what the probability of getting a non-defective what HDT we get it. So that's the Q equal to 1 minus the P and that is 1 minus 0.2. 0.2, and that will give us 0.8. Alright, so now we found the values for our various variables in the formula. So now we just plug them in and then we'll solve with our calculator and get our answers, right? Alright, so we said n is 4, so we have 4 factorial all over n. X is 2, so 2 factorial. And we said what? Sorry. Said n minus x all factorial. So n is 4, x is 2. So we know that the remainder is 2. So we have another 2 factorial. Sorry. Times our p here, which relates to the x. That's defective, is 0.2. 0.2 raised to the power x. X is 2. Times q, which is 1 minus p, and is 0.8. Raised to the power n minus x. So we know that n is 4, x is 2, so 4 minus 2 is 2. Then we solve with our calculator and then we get our answer. So with the p, if the question has said find the probability that only 2 will be called non-defective, so it means that x, which is 2, is non-defective. So the p here should relate to what? Non-defective. And then to rather be what? 0.8 and not 0.2. So you have to read the question carefully and know which one relates to the x, especially in the binomial distribution. Because if you just take the probability in the question like that, but you don't read what the question is demanding, then you might get to answer wrong. So you have to know the probability they are asking for in relation to the x. So what is the x asking for? Is it defective or non-defective? If it is defective, then we know that in the question 0.2. If it is non-defective, then it means that 1 minus 0.2, which would be 0.8. So now use the calculator to solve this. So let me try and use the online calculator and see. So we have 4 factorial, right, divided by, wait, so we have 4 factorial divided by 2 factorial divided by 2 factorial times 2 factorial. So please solve with your calculator so that we'll see whether it's correct. So this is the what I've written here is this side, right? So I'm not coming to write this side. Then we'll have times 0.2 raised to the power 2, right? 0.2 raised to the power 2 times 0.8 raised to the power 2. So we got 0.1536. So let's see from the possible answers. So from here, we have 0.025, which is not this. We have 0.154, and then we got 0.1536. So it means that they rounded it to 3 decimal places. So this will become our answer. I hope you understand this part. All right, so let's move on to the next question. It says, if 2 or more defective HDTVs are found, the whole batch will be rejected. The manager wants to know the probability of rejecting an entire batch of what? HDTVs if in fact the batch has 20% defective TVs. So what the question is saying that now they said what's the probability of getting two? That's in the first question. And then here the question is say if we find more than two, or we find two or what more, then it means that we are going to reject the entire batch, right? So find the probability that we'll be rejecting an entire batch. So that's what they want to know. Probability of rejecting an entire batch is when the TVs have, or the batch has two or more defective TVs. So here they're asking us to find the probability that X was greater than or equal to 2. And then we know that how should I put, in the sample, right? They pick 4 for the sampling. They pick 4, right? And then they're asking us to find the probability that they are going to reject an entire batch. And that is when X is greater than or equal to 2. Then it means that you are going to get what? A rejection. But then you can simply, this one is in two folds. Either choose to do it this way. Since they're saying greater than or equal to 2, it means 2 is part, 3 is part, 4 is also part, because we pick only 4, right? We pick only 4. So it means that 2 is part, 3 is part, and then 4 is part. And then we know that probability, the sums of probability is equal to 1. So if they're asking me to find the probability that X is greater than or equal to 2, then it means that if I know the probability that X is less than 2, I can subtract from 1 and get what? My answer. True? Okay, so now I come to find the probability that X is what? Less than 2. Because if you start, or if you use this one, like probability that X is greater than 2, so you start from 2, 3, and 4. Then I'm using probability that X is less than 2. So I'll have 0 and then 1. I'll finish faster than you, right? So we use that. This one is the same as 1 minus probability of what? X being what? Less than 2. So the reason why we didn't bring less than or equal to is because the question says 2 or more. So it means greater than or equal to that. 2 is part of what the rejection, right? But then we are looking for things that will not give us a rejection. That's less than 2. If it is less than 2, there will be no rejection. But then we are looking for it there being a rejection, that's being 2 or more. So after finding for this probability, subtract from 1 and we get this. So how do we find this probability? So this probability, so let me do it at this way. So the probability of X being what? Less than 2 is equal to the probability of X being equal to 0 plus the probability of X being equal to 1. So the probability of X being less than 2 is equal to the probability of X being 0 plus the probability of X being what? 1. Alright. So how do we find this probability of X being 0? So then, therefore, we use this same formula for each of this. So this is the formula we are using. And then because it's less than 2, not exactly 2, so it means you are finding probability that X is equal to 0 and X is equal to 1. But the formula still holds for each of them. So now here, instead of writing 2, we're having our 0. Instead of writing 2, we're having our 1. So that's how we go about it. Okay. So for this side, we just substitute this 0 at wherever the X is, but you maintain n being equal to 4, the p being 0.2, and then the q being 0.8. Hope you get that. So that's basically how you do it. So we are going to do it, but I'll not write everything here. Just use the calculator to solve it. All right. So now our x is no more 2 here, but it's 0. So we have our n factorial, that's 4, divided by, sorry, our n factorial divided by x factorial. So now x is 0. So you can just punch on the calculator, just go straight ahead. But I just want to do it so that at least someone will also see how to do it. Okay. So now x here is 0. It's 0. No more 2. Because we are looking for this one. So our x is 0. So 0 factorial. 0 factorial times. So 4 factorial, that's the n factorial, divided by x factorial, which is 0 factorial, times n minus x all factorial. So now n is 4, our x is 0. So 4 minus 0 is 4. We have 4 factorial here. Then we multiply it by what? Our p, which is what? 0.2 raised to the power x. And then we know that x here is what? 0, right? Our x here is what? 0. Oh, our first. Oh. I'm doing it again. Oh, no, no. I don't know if I can do it again. You let's try again. 4 factorial. This was my manual calculator, but now I've been done. That is all good. Okay. So 4 factorial divided by x factorial, which is 0, times n minus x, which is what? 4 minus 0, which is 4 factorial, times our p, which is what? 0.2 raised to the power 0, times here, which is 0.8 raised to the power n minus x, which is 4, right? So raised to the power 4. We are getting 0.4096. So let's write it down. So p, the probability of x being 0 is given as 0.4, 0.4096, 4096 plus, so now it comes to 4, probability of x equal to 1. So here it's no longer be 0, but it will be what? 1. But I don't know why I'm not able to at least change, start again. I don't know. Alright, so it's all good because it will help to keep the formula in the mind. So n factorial, which is 4, divided by our x factorial, which is now what? 1, times n minus x, which is what? 4 minus 1, 3 factorial, all divided by our p, which is 0.2 raised to the power what? X, and x is 1, times our q to 0.8 raised to the power 3, plus n minus x, so 4 minus 1 is 3. We are getting 0.4096. So let's look for our answer. So our answer times 2. We're getting, because 0.4096, 0. As they say. So if you want to know, you can multiply one of them by 2 and you know the resulting answer. We have 0.8192. 0.8192. So let's look at the answer and see whether we get 0.8192. Yes. But then we are not done, because we are looking for P being what, greater than or equal to 2, right? But then we found for P being what, a probability of X being what, less than 2. So we have to subtract from 1. So, 1 minus what? 0.192. This is what? 0.1808. So you see, if someone had used this, see this, the answer is here. So you get confused. Oh, I got it. So you just pick it. But I've forgotten that there's 1 here that you have to subtract your answer from. Do you get it? So because of time, I won't go through finding for x equal to 2, 3, and 4. So that way you can try on your own and see whether you get 0.1808. If it works, then we are fine. You can use. But sometimes, what if the sample size is 8? Can you find for 2, 3, 4, 5, 6, 7, 8? I'm not sure you have that time. So you just find for the lesser figures, then you will subtract from 1. But if you can do for 2, 3, 4, 5, 6, 7, 8, 9, 10, then I'll clap for you. All right. So we'll move on to the next question. So what we did was what, under binomial distribution. So you have to know which one or which type of distribution I'm dealing with. Is it binomial, Poisson, hypergeometric? Before you be able to know, oh, okay, so this is what I'm supposed to do, this formula and this formula. If you are not able to identify it, then try all the distribution, their formula, try them out, because definitely one of them will rotate for you. But if you know the features of the distribution, just go straight ahead and use them. That you can save time, right? All right. So the next question says, among 30 people working for a large actuary department of an insurance company, 20 are actuaries and 10 are support staff. If 12 people are randomly chosen to attend a brainstorm meeting with company executives, what is the probability that exactly 5 actuaries are chosen to attend the meeting? So this question, you see so many figures, so many numbers. So, oh God, how am I going to solve this? Just know which type of distribution are you dealing with. This doesn't look like a binomial distribution. Binomial distribution is basically, if it is not this, it is that. You get it? So something about yes or no, defective, non-defective, you get it? But then this one doesn't look like something like that. So we'll say, okay, so what other type of probability do we have? We have Poisson distribution. This too doesn't look like Poisson distribution, because the Poisson usually works with time, like per unit time. But this one, I'm not seeing time here, so it's not Poisson. So it means that is the other type of what distribution, which is what, hypergeometric distribution. And this distribution is just about finding probabilities for certain events without replacement, or certain things without replacing them. So if, let's say, I'm selecting people to, maybe in a class we are 30, right? And then I want 5 people to go for an excursion with me. What will not happen? So if I want five people to go on an excursion with me, if I pick one person, I'm not going to put the person back and then pick another person. So if I pick Amma will stand there. Then it means that now we have 39 students, no more 30, right? Then I'll pick Kofi. It means now we have what 28, right? No more 30. So that is what the hypergeometric is all about. So picking things without replacing them. So find the probability for such. So first, you write the formula down, then be able to what, okay, so where do I find this variable? How do I find this variable? You get it. So the formula is n. It's kind of rough, but if you take your time, it's easy to grasp the formula. So realize I'm writing capital N in capital X, not small n and small x. Then we have combination, small n minus small x. And then we have big S combination, small x. So this is a combination question. You get it? All divided by big N combination, small n. So this is the formula for what hypergeometric distribution. So when you read the question, you realize that it's not binomial. It's not talking about only two things. If it's this, if it's not this, if it is that, you don't find that in the question. And it's not talking about time, finding probabilities of people coming within this time per 30 minutes and within 1 hour. It's not Poisson. Then it means it to be hypergeometric, especially when you are seeing so many figures in the question. It means it's hypergeometric. But then you may never know. So you always, if you are not sure, just try out each distribution, and eventually you'll be able to come out with the appropriate one. Get it? So this N is standing for the entire population. So the whole of UGBS 301 class. So that's the capital N. The capital X is talking about, sorry, the capital X is talking about a part of what the entire, how should I put this? A part of the entire population. A part of the entire population. So let's say in UGBS 301, we have 50 students. So out of the 50 students, we have 30 BSc students. So that 30 is out of the what entire population. You get it? So the 30 is what the entire population, sorry, the part of the entire population, and that's the what capital X. Then when we talk about the small n, it's talking about a sample out of the entire population. A sample out of the entire population. So let's say, so like this question, we have 20 students here, 20 students being BA students, right? And then we have 50 UGBS 301 students. Out of the 50, we have 20 being BA students. So definitely 30 will be BSc students. And they are telling us that when we are doing the sampling, we're not picking from only the BSc side. We're picking from the entire population. So that's random picking is the small n. You get it? That random picking is the small n. Though we've been able to identify that 20 students are BSc, 10 students are BA students. Do you get it? But the sampling we are doing is not only about BA students, but we are picking from the entire 50 UGBS 301 students. So you wouldn't know whether I'm picking the one I picked was a BA or the one I picked was a BS. So that becomes your small n, your sample, the sample size. Then the small x is what out of that sample size. What are you looking for? So now the X is narrowed to only the random picked people, the randomly picked students, the sample size. So that's the small s. So that's basically the variable. So you have to identify. So it's not difficult. Just identify which is my bigger n, which is my bigger s, which one is the small n, small x. You get it. So from this question, the big N is the 30 because it says among 30 people working for a large actuary department of an insurance company. So in that department, the entire population is what? 30. Get it? They are saying that 20 are actuaries and 10 are what? Support staff. If 12 people are randomly chosen to attend a brainstorm meeting with what company executive, so these 12 become the small n because out of this 30 that they are picking this 12, not from what these 20 actuaries or 10. So because it's talking about randomly chosen, this becomes a small n. And then they are saying, what is the probability that exactly 5 actuaries are chosen to attend the meeting? So now they've narrowed it to what? Only actuaries. So now our goal is to pick an actuaries person. Actuarist, I don't know. Actuarist. Any way you pronounce it. So now because they've narrowed it to only actuaries, it means that our big X will become what? The actuaries figure. And then the small x will become this 5. I don't know whether you are getting me. If you have any question, you can leave it in the comment section. And I'll gladly help with that. Okay. So the big N is the 30. That is the big N because it's talking about the entire population. And among the entire population, we've divided people into actuaries and support staff. But then we are doing the random picking. We don't care whether you are an actuaries or you are what a support staff, or you don't go to only the actuaries group to pick. But everybody is present and we are picking. So that 12 becomes what? A small n, which is the sample size. Then the question is saying that what is the probability that we select exactly 5 actuaries? So now our goal in picking these 12 people, we are assuming or we are hoping to get 5 of them being actuaries. So now our small x is what? The 5. So if 5 of them are, our goal is to pick actuaries, that means that we what? Concentrate, or our big S will become the what? Actuaries population, which is the 20. So you just plug them into the formula and you get your answer. But this, I will use my calculator because if I'm to use the online calculator, it's going to take much time. Okay, so I'll use my calculator. So we know that n. Okay, so with the calculator, realize that under the AC, I don't know if you can see, but under the AC, you see the division sign. You can see n combination R there. So if you want to access that, you just press shift and you press the division button and you get a combination. How do you get the N and the R? So the N is this upper part and then the R is the lower part. Okay. So you bring your division sign. I don't know if you can see, bring your division sign. Then at the upper part, we have what? N minus X, and N is our 30, and then X, big X are 20. So 30 minus 20 is 10. So we have 10. This is the N for the combination. Then you press shift and then the combination, the C will come. Then our R is the lower part, which is what? N minus X. That's the small n minus small x. Small n is 12, X is 5. This is what? 7. So we get 7 times this one. The X is the upper part, so that will come first. So our big X is what? 20. You have 20, then press shift in the division sign. Then our R which is the down part is the small x, which is 5. Then divided by our big N, which is what 30. Then you press shift and division sign. And then the small n is what the 12, and you bring the 12. So you're going to get 0.0215. So when you round it, you get 0.022, and it's over here. So 0.022. So that's basically how to use the calculator. But try it out and see whether you get the answer. So this is the formula you use. So I know number 4, you can do it. So you first draw the curve to know how it will look like. So since this is z, and then it means that the mean in the z distribution is 0. And then we have 0.5 will be 0.58 will be here, and then 1.15 will be here. So we are looking for the region here. We are looking for this side. So just find the z value for this one, and subtract. You find the z value for this, the z value for this from the table, and subtract this figure's own from this, and you get your answer. So you're getting something like this. So if you want to know how to do it, watch my normal distribution video and then sampling video. So I think basically that is it. And then this is matrices question. So if you want to know more of matrices, watch my matrix video and you'll be able to do it. So this one is basically prices. This is a row vector and this is a column vector. So it means that the P is a what? How many rows are here? 1. There's only 1 row. But how many columns? 3. So the P is a what? A 3 by 1. Sorry, a 1 by 3 plus 1 row and then 3 columns. So a 1 by 3 matrix. Then the kill is what? A column vector. Means that if it's a column vector and it's having 3 figures, that it has what? It has what? 3 rows and then 1 column. So 3 rows and then 1 column. So the rows 3, and then we have 1 column. So you can multiply, but then the answer will not be in the solution. So you can try it out. So that's basically a short video on solving some probability questions. So you have to first know the type of probability you are dealing with. Then you'll be able to identify the formula that you are supposed to use to solve what's there. So I don't want to touch on Poisson because maybe I might confuse some people. But then if you want me to do something on Poisson, just let me know and I'll do a video on that. Alright, thank you so much for watching this short video. God bless you, bless you, bless you so much. And I pray that as you go through, you'll be able to understand and solve more questions on your own. God bless you. Stay blessed. Till next time, it's goodbye for now.